For perfect complements, we're also not going to be able to use our Lagrangian method. And the reason is because it's not differentiable, right? Remember that we can't take the derivative of the minimum function, so there's no way for us to get the marginal rate of substitution in order to get our optimal consumption ratio. Instead, the optimal consumption ratio is sort of defined in the problem, right? These are perfect complements that we only like to consume in a certain ratio. And so we find the optimal consumption ratio by looking at the terms in our minimum function. And in particular, we can find it by setting them equal to each other. Excuse me. So here we'll find our optimal consumption ratio by setting equal our two terms in our minimum function. And so, we got this equation, x equals 4y or y equals 0.25x. That describes the optimal ratio of the goods we will consume. It's also the ray that passes through the kink point in our indifference curves, our L-shaped indifference curves. Now, in order to figure out the actual amount of x and y that we purchase, all we need to do is to combine that with our budget constraint, right? So our budget constraint here is 30 equals x plus 2y. And so what we have is, we can plug this in for y, and I've got 30 equals x plus 2 times 0.25x. So that's 1.5x equals 30. So I divide and I get x is equal to 20. Then I can plug that back into my optimal consumption ratio here to see that y will equal 5. And then to show that on the graph, what I can do is to draw my budget constraint. That's always the best way to start. So let's rearrange our budget constraint to be a function of y. So 2y equals 30 minus x. Y is equal to 15 minus 0.5x. And 30. And then at this point, 25, that is going to be my highest indifference curve in the budget set. I will have more indifference curves here, right, at the same ratio, so like 1 and 4. And the kink point will follow this ray out from the origin that has this equation. Good. So in this case, we didn't need to take any derivatives. We simply set the terms in the minimum function equal to each other, and then combine that with the budget constraint to solve for your optimal consumption bundle.